So I think it's easiest, and I wish teachers would say this all the time, that if we just use the line tangent rather than trying to memorize some silly formula. Cranky Calculus, we are here to talk about linear approximations, and we're going to learn some little hacks that we can use to help us out with understanding these. So let's just get rocking and rolling here. So there's a formula that you can memorize here, which is the equation of a tangent line, and I totally am okay with you memorizing that with the approximation as well. So if you can see, the equation of the tangent line and the approximation are practically the same thing, and we get this all from this point slope form equation, which is y minus y1 equals mx minus x1, and I'm going to show you how you are going to use that in this video. So we're going to go ahead and tackle this first problem right here. We have use a tangent line at 1, 2 to this f of x, which is 2x e to the x minus 1 to approximate 1.1. So this is an equation that I don't want to plug into 1.1. That's too much work. It's going to be difficult for me to figure that out. But what I can do here is I can find the tangent line to this function, and then I can approximate f of 1.1. So let's get at that. So the first thing we're going to do here for my tangent line is to find out what f prime of x is. And this is going to involve product rule. So I'm going to have my first function here is the 2x, and then my second function here is going to be the e to the x minus 1. So the derivative of the first here is going to be just 2, so it's 2e to the x minus 1. Product rule plus 2x, the derivative of e to the x minus 1, it's a little tiny baby chain in there. So this is going to be e to the x minus 1. Now, I want to find the slope of this tangent line, and that's going to be f prime at 1. So if I were to plug in a 1 here, I'm going to get 2 times e to the 0 plus 2 times 1 times e to the 0, which is going to give me, it looks like an answer of 4. So my slope at this point is 4. So my tangent line is going to be y minus y1, which I do have that here at 2. I have x1 while I'm at it. So y minus 2 equals the slope, which is 4, and then I have x minus 1. So I'm going to use this as my approximation. So y equals 2 plus 4, x minus 1. So for my approximation at 1.1, it's going to look exactly like what you see right above there. It's 2 plus 4. Replace the x with a 1.1. And we're going to get, oop, I forgot to subtract 1. Got a little ahead of myself. Minus 1. So now from that, I'm going to get 2 plus, looks like 0.4. So my approximation here is of 1.1 is approximately 2.4, and that's really hard to do, is to plug that in right there. So I think it's easiest, and I wish teachers would say this all the time, that if we just use the line tangent rather than trying to memorize some silly formula. I do want to talk about error, because sometimes we are asked what the error is of the actual value and the approximation. So just so that you are aware that we have error is equal to the absolute value of the exact minus the approximation. So for our specific problem here, our exact value of f of 1.1, I did some little digging up on the side over here, and I found out that this is going to be, I'm going to do this to the nearest thousandths, is 2.431, and our approximation is the 2.4. So our error is going to be 2.4 minus this 2.431. Absolute value of that, because I only care about the positive value for any type of error. So our error here for this problem is going to be 0.031, which means that we are pretty close to estimating what this value of this weird old function is. For our next problem here, we're going to find the tangent line to the graph of this f of x, which is a square root function, root x plus 1 at x equals 41, and we're going to use that to approximate what the value of root 50 is, because we can't find the value of root 50, but we can go ahead and use a tangent line to come up with a really, really great approximation for it. So what we're going to do here is, real quickly, I need to find out my y value, because in the last problem, I had my x, I had my y. This one, I only have my x, so if I were to plug in a 48 into this function, so I would get 48 plus 1, I'm going to get root 49, which is 7. So I have a y value of 7. So now I need to find my slope. In order to find my slope, I need to find my derivative of x. And I'm telling you right now, you need to memorize your square root derivative formula. Okay, so d over dx of root x is 1 over 2 root x. If you can memorize that, you're going to go a long way. So this derivative, it's a little tiny chain. That's 1 over 2 root x plus 1. And now we're going to go ahead and plug in our x value of 48. And it's going to be 1 over 2 times root 49, which is 1/14. So now this is going to represent my slope. So my equation for my tangent line for this function here is going to be y minus, I have my y value, which is 7, equals 1/14 of x minus 48. Yep, everything's looking good. Okay, so now I'm going to use this tangent line here. Just move that 7 over so this looks like my approximation. And now I'm going to plug in a 50. So this is my estimation for, oh, actually, you know what, real quick, let's talk about this. If I'm trying to estimate root 50, if I set this in my equation, which is x plus 1, my x value is actually going to be 49. So, knowing that, I'm not trying to find f of 50, no. I'm actually trying to find f of 49. So if I were to find my approximation for 49, I'm going to get 7 plus 1 over 14 times 49 minus 48, which is going to equal 7 plus 1/14, really, which is a totally awesome answer. I'll make that a big old 17, 7 and 1/14, because we're just trying to estimate, so we don't need to get decimals as our answers, but that number is going to approximate our value of root 50. So this is also the approximation of square root of 50. That is going to wrap up this video. Please like and subscribe for more.